Hello everyone, so in this video let us talk about one more problem from LEETCODE. The problem name is minimum number of arrows to burst balloons. The problem statement goes like this, that you are given that there are some hemispherical balloons tapped on a flat wall that are represented in the XY plane. The balloons are represented as a 2D integer array points where points of I mentioned the x of x start and x end denotes the balloon's horizontal diameter. Okay, now it is stretched along x start and x end, so you can assume like a number plane, and from x start and x end there are different balloons. Now you do not know the exact y coordinate, and that is also not required. Okay, you just assume that there are some balloons, and the starting diameter of that balloon, like you can assume some spherical balloons, the starting x of start and x of end is given to you for every balloon. Now you have different arrows. So arrows can be shot directly upwards in the positive xy direction. Okay, from different points along the x-axis, from any point along the x-axis, you can fire different balloons. A balloon with a x start and x end is burst by an arrow if it is like if the balloon is in the path of the arrow, if it burst along like whatever balloons are in that particular zone, all will be burst if we fire a balloon at any x coordinate. And there is no limit on the number of arrows you can shoot. Any number of arrows you can shoot. Find, like, given the array points, like how many different balloons are there and what is the x start and x end, find a minimum number of arrows you need to shoot to burst all the balloons. That's the overall problem. Let us take one example to understand and visualize it more easily. So let's say that there is this, you can just assume that you are a person standing here, okay, and you shot arrows like this in the positive y direction. Okay, and there are different balloons. Let's say there is some balloon here, so there's this x and y, like this is some width of this. Okay, now this y coordinate doesn't matter at all, because if we just have to talk about this particular width of this balloon. Okay, let's say there is one balloon like this, one balloon like this, or let's take another pen. Let's say one balloon is like this, of this width, one balloon is like this, one balloon is smaller like this, one balloon is like this, one balloon is like this. So the different balloons like this, and you have to shot these arrows such that a minimum number of arrows you have to like burst all the balloons. Now if this arrow is taken, then it will only burst this balloon. If this arrow is taken, then it will burst both of these. If this arrow is taken, it will burst this, and maybe we have to fight one more arrow, and then 4 minimum arrows are required to burst all of these balloons. That is the overall problem statement. Now you can pause this video and try to think over that. Now the overall idea which you can directly, like, very easily come up with is, or let's take one small example here as well. What you can observe here is that, let's say, what is the first arrow you will use eventually. Okay, let's remove out any of these arrows, whatever. Let's say we'll start from the very first. You have these balloons that is given to you, so you are given these ranges. Okay, what is the starting and ending of the balloon? Okay, now you first sort out all of these ranges. We'll talk about how we can sort them out, but we have sorted them out. Now the sorting will be such that they will be like, this is one of the range, the second range, and third range, so on. Now let's say if I fire this here, then is it better to fire like at this point or to fire at this point, because this will burst two balloons? Okay, or can we fire at this point? Oh, not, this is not a straight line, but let's say like at this point it will fire 3. So what you can directly assume is, or like find out, is whatever is the maximum overlapping with a particular segment is, we'll take that particular thing. But how we can find it out? The overall idea again boils down to that, let's say we will have, like, how we will sort out these segments. So we will sort out by the ending points. Whatever ending point comes first, we will sort them out according to ending point. So can you just sort out them? So the first ending point is this, like closest ending point. So this is the first that will be in the sorted array. Then the next ending point comes this. This is the second one. This is the third one. Then this is the fourth one, and this is the fifth one in the sorted array after we sort them by the ending points. Now what will happen is, like, because if we want to sort out all of these arrays, there are either two things, like either we will sort it by the starting point and ending point. The ending point is generally used when we try to find out what of them are coming close to each other, that are ending at the very beginning. So okay, so if you want to sort these arrays, generally it's sorted by the ending ones only. Now what you can directly do is, let's say that my first point is that I will eventually have to like burst the first balloon. So let us take that I will burst the first balloon by one arrow. But is there any more arrays that are merged in this first array? If I can find out, eventually I will just use one arrow to burst this. So I just actually have to find out the non-overlapping arrays, or like you can say like non-overlapping balloons. Okay, the number of non-overlapping, whatever are overlapping will be burst in that over, like in the uh, balloons which are overlapping, we will shoot them in one go only. So number of non-overlapping balloons are the ones which eventually we have to take an individual arrow to fire and burst them out, and then that's the answer. Because see, so let's say what you can do is that let's say that this is one of the arrays we'll start with, because that's the first array, we have to always burst that. Now is there more array that it coincide with? So what I'll do is, let's take to the next array, because we have an array that is sorted. Move to the next balloon. Does this array and this array coincide? So we'll just take the end point of this array and the starting point of this array. If they coincide out, then obviously they coincide out. So it means that I can take only one balloon to like burst both of them. Okay, let's move on to the next you can say balloon, and they also coincide out. So again, so because they're overlapping, so I just have to find a non-overlapping. They're overlapping, so it actually just means that only one arrow is required to burst all of them. Okay, let's move on to the third balloon. Does this overlap with the first balloon? Because see, I have decided that I will take one arrow to burst the first arrow, like first balloon, and whatever comes in the way of this first arrow, I will also burst them. So eventually I will fire from here. But because I will be like, I will only be comparing with the first balloon only. So this is overlapping with the first balloon, this is overlapping with the first balloon, this is overlapping with the first balloon also. No. So which means that now the first arrow is not used to burst this out. I will have to individually use another arrow. So now my like balloon of concern is this. Now I'll check that whether any more balloons are overlapping with this, because if any other balloon is overlapping with this, I will shoot that balloon with this balloon only. I hope you get the point. So I have to just club up all the balloons that are coming up under one of the balloons, and I'll just shoot them out in one go. So no balloon is overlapping with this. So I will next go to the next balloon, whether this balloon is overlapping with this, because all the previous balloons are overlapping with this, so that will form one group. Now I will go to next group, like whether this is overlapping with this. So this is not, let's say. So this will form one more another group. So now I'll go to the next array, whether this is overlapping with any other that is on the right side. There is no more other side, so I will have to take one more you can say group. So three you can say like arrows are required to burst all of these balloons. That's the minimum answer and minimum number of arrows. So let's move on to the code part now. That's the overall logic for this problem. So what I'll do is that I will first sort all of these array of points by the end point. So I will use a custom comparator function. So just compare that. If a1, that is the second point of any point that we're comparing with this points array. If it is smaller, then only, like if it is smaller, then only we'll reverse it out and then we'll make a sorting. So we have the sorted array after like the sorted array of balloons after doing this sorting operation. Then the total is 1 eventually, obvious, because there is like always one balloon at least to burst. So the answer is one arrow is always required. Then we'll start on the second point. Okay, so we will always take the first segment that we have to burst with the arrow, and then starting on the second segment, we'll just check that whether it is overlapping with the previous segment that we have talked about. So this is the last segment that we have to check that whether all the subsequent segments are overlapping with this segment. Okay, until we move to the next segment. So this is the last segment, that is the 0.0, because we have already taken that in the concentration. Now let's start on the second segment, that is I equal to 1, and whether this segment is intersecting with the last segment. If it is intersecting with the last segment, then it is fine, we'll go to. But if it is not intersecting, this case is not intersecting. When it is not intersecting, what I'll do, then I have found a new segment, a new group. I have to like previously leave the other group aside. So now because we have moved to a new group, the new group is the point of I. Okay, the new point that we have taken, because this point is not overlapping with the previous group. So we will now make my last equal to this point of I, that is the new group that we have created, and total plus plus, because now we have started a new group. So this is actually just checking out that whether the previous group, that is the, so let's say we are always taking one segment, that this is the new segment, and I'll just check out moving from left to right what all segments are intersecting with this, whether this is segment intersecting with this is intersecting. If they're all intersecting, we'll just keep on moving forward. But when we find out that this is not intersecting, that this group is not intersecting with this, Then I will make this as the new segment and keep on moving forward, that how many balloons are now intersecting with this segment, because whatever the current segment, I take that and see that how many non-overlapping segments are there and just count the total. When a total, I just print out the total number of answer of total number of arrows that are required. So talking about time complexity, what you can see is that we have sorted, so O of n log n here, and then there's a for loop also, that is O of n, but the overall time complexity comes out to be O of n log n due to sorting. And I think so no more space is actually extra required because sorting is in place, like in the whole array only, and it's like constant variable. So yeah, constant space is actually required. So that is the word complexity and space complexity for this problem. Thank you for watching this video till the end. I will see you in the next one. Keep coding and bye.